Here in this blog, we are going to see about um, unit in unit 6 IBFS, that is initial basic feasible solution by finding northwest corner rule, least cost method, Vogel's approximation method. By all these methods, we can find out the initial basic feasible solution. And the structure for this unit is the overall structure for this unit is nothing but it contains objectives, introduction, method for finding initial basic feasible solution, northwest corner rule, least cost method, Vogel's approximation method, and overall sum up, some keywords, and some terminal questions. So all these things are contained in the unit 6. Now we can see the objective of this unit. In this unit, we will be able to check whether the transportation problem is balanced or not. So what we have seen in the previous unit itself, balanced means if your supply total and demand total are same means then it is said to be balanced. Otherwise, we have to make a dummy row or dummy column to make it as balance, and then we can proceed a problem. Here, the next step is you need to determine the initial basic feasible solution using various methods. Here, the various method refers here means northwest corner rule, least cost method, Vogel's approximation method. All these things are the different models used to find out the initial basic feasible solution. An introduction part. Here, an introduction is the initial basic feasible solution is a significant step to achieve the minimal total cost. That is, it is very important to get the minimum total supply, that is total cost of the transportation problem. So with with this basic solution only, we can get the minimum total transportation value. And this involves a initial solution to the given transportation problem. So that is, this involves the initial solution means the initial basic solution only. It's nothing but an initial solution. And there are several methods available to obtain the initial basic solution of a transportation problem. For finding the initial basic feasible solution, total supply must be equal to total demand. So whatever might be the method, if we want to start, first initially we have to check whether the given problem is balanced, and then only we can proceed the problem. So this is a major introduction what we are having about the transportation problem. That is, transportation problem means you need to find the initial basic feasible solution. Next thing is methods for finding initial basic feasible solution. What are all the methods we are having for finding the initial basic feasible solution are already what we have described in the previous thing itself. It is clear the three models we are having. First one is northwest corner rule, second one is least cost method, and third one is Vogel's approximation method. So these three are the methods for finding the initial basic feasible solution. Next, northwest corner rule. This method starts at the northwest corner cell of the table. Already we have seen the model of the transportation table. So in that table, we have to start a problem by starting in the corner cell of the table. That is upper left corner cell. Upper left corner cell of the table only you have to start the problem. That is upper part already you know. In that upper part, in the left upper, you have to start in the corner part. What is the first step means allocate as much as possible to the selected cell and adjust the associated amounts of capacity and requirements by subtracting the allocated amount, and cross out the rows with a zero supply or demand to indicate that no further assignment can be made in that row. That is, you have to make an assignment properly. You have to select the corner part. In that corner part, that supply total you have to see and the demand total we have to see. In that one, you have to take the minimum. that you can allocate to your upper part, that is corner cell. After allocating that, you have to strike out that value whether it is row or column. So similarly, if you're taking that from the row means you can subtract from the column. If you're taking from the column means you have to subtract from the row. So this is a basic thing generally you have to do. This steps and all you can understand by clearly if you are doing the problem. That is, cross out the row with a zero supply or demand to indicate that no further assignments can be made in that row or column. That is, if you are crossing once, if it has been crossed means you can't allocate. That is, you can't assign any other part in that one. So if both the rows and column become zero simultaneously, cross out them, cross out one of them only. That is, if both are becoming zero means any one you can cross it and leave a zero supply or zero demand in the uncrossed out rows. That is one thing you have to keep it as it is. Only one thing you have to cancel. That's a meaning there. And regarding your step 3, if exactly one row or column is left uncrossed out, then stop. If any one thing is kept as uncrossed means you have to that is, if it's left means you have to keep it as it is. Otherwise, move to the cell to the right if your column has just been crossed, or one label if your row has been crossed out. So if you are proceeding like this, you have to move on forever. If it is, if all these things are completed means you have to go to our step 1 once again. So you have to see, you have to start from the upper corner, that is upper left corner cell. In that one, you have to see the supply total and demand total, that corresponding that is supply and demand value. Which one is minimum, you have to take that one and allocate in that cell, and that should be crossed out. That crossed out value must be taken either from the row or column. So in that one you can do our calculations till it is, we can, that final value is coming in the balanced format. If you do the problem itself, you can understand when it is becoming the balanced one. The next one is nothing but the least cost method. The least cost method is also similar to the northwest corner. In the northwest corner method, we have started our allocation from the upper left corner cell, upper left corner cell. But here in the least cost method, the total transportation table, you have to see where you are having the minimum cost, where you are having the minimum cost, that that you have to start your problem from there only. In that one, you see the corresponding row total and corresponding column total, that is corresponding supply and demand. You have to see which one is minimum. That value you have to allocate to that cell, and that allocated value has to be subtracted from the, either if you are starting, if you are taking from supply means you have to cross it in the demand. If you are taking from the demand means you have to cross it in the supply. So in such a way, you have to carry on your calculation for your least cost method. So you have to, you should not start from the corner cell. You have to start only from the minimum value in the transportation table. You have to start your value from the minimum value of the transportation table. So now we can see what it is given for us in the least cost method. The least cost method is also known as matrix minimum method, in the sense we look for the row and column corresponding to which Cij is minimum. So you have to see which one is minimum totally. This method finds a better initial basic feasible solution by concentrating on the cheapest routes. That is, if you are doing your allocations by using the least cost method means your transportation value will be more less. That's the thing they are having here. And instead of starting the allocation with the northwest cell, in the northwest corner method, we start by allocating as much as possible to the cell with the smallest unit cost. That is, instead of starting in the uppermost corner, you can start, if you are starting our problem with the least cost means it could be somewhat better. If there are two or more minimum cost, then we should select the row and column corresponding to the lower numbered row. You have to more than one, if you are having means any one thing you can choose it, and then you can start our calculations there. If they appear in the same row, we should select the lower numbered column. So if we are appearing in the same row, that the least numbers means you have to select the lower number column. We then cross out the satisfied row or column and adjust the amounts of capacity and requirements accordingly. You have to do the adjustments later on according to the problem. If both a row and a column are satisfied simultaneously, both rows and columns are satisfied simultaneously, one is crossed. Now we look for the uncrossed out cell with the lowest, that is smallest unit cell, and repeat the process until we are left at the end with exactly one uncrossed out row or column. So all these things are nothing but the way in which we are allocating step by step, and finally we will be start completing our problem if everything is becoming balanced one. This is a thing they have explained it to you for our by method of finding the least cost method. And next thing is Vogel's approximation method. Vogel's approximation method is a improved version of the least cost method. That is, it is also a generalization of the least cost method. So in northwest corner means we are starting our allocation with the upper corner, that is upper left corner cell, and least cost method means you are starting your value with the minimum value. And Vogel's approximation method is that producer that generally produces a better solution. That is, it is an extension of the least cost method. So here the answer what we are getting will be somewhat better than least cost method itself. So we will be seeing what is a step we are having for solving by using the Vogel's approximation method. Your step one is for each row of column, for each row of column with a strictly capacity, positive capacity, determine a penalty by subtracting the smallest unit cost element in the row or column from the next smallest unit cost element in the same row or column. That is, you have to start from the row. You have to take the minimum value and the next minimum value, subtract and write it outside with the bracket. And similarly, you have to do this thing for all this row. That thing what you are doing, this that is the thing what you are doing for subtracting the minimum and the next minimum is said to be called as what means penalty. The penalty value you have to calculate for each row and for also each column. Then identify the row or column with the largest penalty. So once if you are marking the penalty, you have to see where you are having the largest penalty among all the rows and columns. If the penalty corresponds to one or more or rows or columns are equal, we select the topmost row and the extreme left column. That is, you have one or more penalty values are same, higher, larger penalty means we can select the topmost row and extreme left column in that case. Next, we select Xij as a basic variable. If Cij is a minimum cost in the row or column with the largest penalty, we choose a numerical value of Xij as high as possible, subject to the row and the column constraint. And depending upon whether Ai or Bi is a smaller of the two, ith row or jth column is crossed out. That is, wherever we are choosing the highest penalty, if you are choosing in the second row means in that second row, you have to see which is the least element there. There you have to stop the allocation. If you are choosing the highest penalty in the third column means you have to see which is the least value, least cost in the third column. Then you have to start our allocation. So this is a major thing you have to use for our VAM method. Then step 4. The step 2 is now performed on the crossed out rows and columns until all the basic variables have been satisfied. So these are the steps. So basically what are all the steps we are having here means for northwest corner rule, we have to start our allocation from the upper left corner cell. And for least cost method means you have to start your allocation from the minimum value of the given content, that is given transportation table. And VAM method means you have to calculate the penalty for each row and column, and you have to start our problem from the highest penalty. In that highest penalty only least element has to be taken. So penalty means it is nothing but generally the minimum that is a subtracted value of minimum and the next minimum. So this is the thing you have to do for all the three methods. So now we can see what you have to do for if you are having the problem with the transport, that is with the if you want to find out your minimum cost for the given transportation problem, how can we find that out? By using northwest corner and least cost method and the Vogel's approximation method. Now we can see. So you have to find out the initial basic feasible solution for the transportation problem. So this is a problem, and you have to find the minimum total transportation cost. Here the supply values are 7, 12, 11. If you are adding this 7, 12, 11, you'll be getting 30. Similarly, in this demand value 10, 10, 10, if you are adding means you will be getting 30. So you can directly say that the summation AI equal to summation Bj. This is summation AI value, and this is nothing but the summation Bj value. The given transportation problem is balanced. If your supply total and demand total are same, then we can say that the given transportation problem is balanced. And there exists a basic feasible solution to the problem. Now we can go for our least cost, that is northwest corner rule. That is northwest corner rule. How you have to do it here means using this method, the allocations are shown in the table. Here, which is the northwest corner means in the entire table, this corner, the one what it is marked in the upper cell, that is upper left, this is the upper left part, corner cell. Here this is the northwest corner. In this northwest corner you see what is the supply value you are having 7, and here the demand value you are having 10. So in this one, the in the 7 and 10, the least value is 7, so 7 has to be allocated for 1. 7 has to be allocated for 1. That 7 have to take away from this 10. So if you're taking 7 from 10 means how much you will be having there means you will be having only 3. So what's the thing you will be having here means so in this corner you're allocating the minimum value here. If you're allocating that minimum value, take that minimum value from the corresponding column total. Next you will be getting there means 3 only, and they are giving the shade here also. So you leave this row for further calculation. If you're taking this row for the further calculation, next you will be having only this two row. In this two row, you can identify that the 0 is the upper left corner of the cell. Upper left corner of the cell, you will be having here 3, because in the previous step this 10 has been converted into 3. So here you will be having 3, and here you will be having 12. So in among this two value, the least value is 3. So take down the 3 and cross out this entire column. Cross out this entire column means you should not have 0 and 3 for the further calculation. Here we didn't have this entire row for further calculation. Here once if it is allocated means that either that row should be taken or that column should be taken for the further calculation. So take down this 0 and 5 for the that is 3 for the further calculation. So if you are subtracting this 3 from 12 means you will be getting the value as 9 there. So you can see the remaining. So if you are taking all those things, what is the thing you are having here means 4, 2, 1, 5. Here 12, that is a 9, 11, 10, 10 you will be having. In this one, this is the uppermost, that is a corner cell of the given transportation table. In that one, you see the row, that is row total 9 and column total as 10. So if you are have which one will be minimum means 9 is the minimum. Enter that 9. If you're taking that 9 from 10 means you will be getting the value as what means 1. So here it is wrongly written as 8, but it is 9 only. So you can take that 9 from this 10 and you will be getting the value as what means only 1. And take that row for the further calculation. So you'll be getting only 1 and 5. So 1 and 5 means in this 1 and 5, already this 10 has to be converted. This 10 has to be converted as 1. Because you are taking 9 from this 10, you will be getting the value as what means 1. And then in this 1 and 5, that is you have to identify which is minimum, either 1 or 11. 1 is minimum, so allocate that one here. This one should be taken from 11. So you'll be getting 10 and 10 for the 5. So this 10 can be allocated for 5. So therefore you are getting the balanced value here. This is the thing you have to get it. Here 10 and here also 10. If you are not getting that values as balanced one, means our problem what we have did is wrong. The way what we have calculated so far is wrong only. So you have to get only balanced value after finding the allocations also. So this is the methodology for doing the transportation problem by uh, northwest corner rule. And once again you have to draw the entire table, and then where and all we have allocated, then that all you have to write it as once again. For 1, we have allocated it as 7. For 0, 3. For 4, 9. For 1, 1. And for 5, 10. All these things are the allocations we have made by using the northwest corner rule. And the initial transportation cost value, what we are having here means you have to multiply, that is 1 into 7 plus 0 into 3 plus 4 into 9 plus 1 into 1 plus 5 into 10. We'll be getting the value as what means rupees 94. So this is the thing you have to do for our northwest corner rule. It is somewhat simple thing only. Next, the same problem can be carried on by using the least cost method. Least cost method means you can identify in the given table, in the given entire table, 1, 2, 6, 0, 10, 4, 2, that is 0, 4, 2, 3, 1, 5. Here the least among all these values is nothing but 0. So you have to start your allocation from 0 only. In that 0, you see your corresponding column value and row value. Here it is 10, here it is 12. The least one is 10 only. So you allocate the 10 here and cross out this entire column. Cross out this entire column. This 10 should be subtracted from 12. So 10, if you are subtracted from 12, means you will be getting the remaining value as what means 2 only there. So you can start your next allocation like this. How can we start our next allocation? Means 2, 6, 4, 2, 1, 5. In that entire value, your one here, the one is only the least value. So in this least value, the corresponding column value is 10, row value is 11. So among these two, the smallest value can be entered here and cross out this entire column. Cross out this entire column and take down the 10 from this 11. Take 10 from this 11 means you will be getting only 1 as the value there. And you can start our further allocations like this. In this 6 to 5, the smallest value is nothing but what means 2. In that one, we can see our row total and column total, and then you can supply, that is you can take down that one, and if you're taking 2 from this 10 means you can have it as what means 8. So what are all the things we are having here means 6 and 5. In the 6 and 5, 5 is the least value. So in this 5, you can either have 1 or 8. Since 1 is minimum, you have to enter that 1, and 1 you have to subtract from 8. So if you are subtracting means what you will be getting there means 7. So here the values are getting balanced 7 and 7. That 7 should be entered to that corresponding cell. If both are equal means then only the given problem is balanced. The things what we have done so far is correct. That only gives an identification that the thing what we have done so far is correct, and our solution is basic feasible solution. So what are all the allocations we have made? All those allocations we have to write it in the table once again, and then we can calculate the initial transportation cost as like this. That is 6 into 7 plus 0 into 10 plus 2 into 2 plus 1 into 10 plus 5 into 1. So the total amount what we are receiving from this least cost method is nothing but what means 61. So this is the second method, that is the least cost method. The third method, it is nothing but what means the Ogle's approximation method. Ogle's approximation method means you need to calculate the penalty value. We need to calculate the penalty value for our transportation cost. That is, once again, we will be having the table like this. The first row, the least element is 1. Next to another, next least element is 2. That is among 2 and 6, and least element is 2. So 2 minus 1 is nothing but 1. Write down here with the bracket. This is the penalty. Similarly, in the second row, the least element is 0. Among the remaining 2, the least element is 2. So 2 minus 0 is 2. Third row is 3 minus 1 is 2. So this is row penalty value. Column penalty value means 0 minus 1. That is 1 minus 0 is 1 and 1 minus 2 is 1. 2 minus 5 is 3. So this is the penalty value for the entire column. Among all these penalty value, the value which you are writing with the bracket, it is said to be called as what means penalty. And among this penalty value, you have to identify that which one is bigger. Here we are having the penalty value as 1, 2, 3. So normally we can observe that 3 is the biggest value, and you have to start your allocation in along this 3. Along this 3 you are having 6, 2, 5. In this one, which element is least? 2 is only least. There you have to start your allocation. In this 2, we can see the column value is 10, row value is 12. So column 12, 10 and row 12, choose the minimum, which is your minimum. 10 is minimum. 10 you can write it there and take down the 10, 12, that is 10 from 12. You will be getting it as what means 2 only. So that entire column you need not enter for the further calculation. So what is the remaining thing we are having here means 1, 2, 0, 4, 3, 1. So in this one, you need to calculate the penalty value in the beginning. Penalty value in the beginning means similarly least one is 1. Next, automatically you are having only 2. So 1 minus 2 is 2 minus 1 is going to be 1. 4 minus 0 is 4. 3 minus 1 is 2. Here in the column, 0 minus, that is 1 minus 0 is 1. And 1 minus, that is 2 minus 1 is 1. So among all these penalty values, you have to identify that which one is the maximum penalty value. There you have to start our allocation. If this here, the highest penalty value is 4. In along this row, you choose which is the least element there. Your least element is 0. In this least element, you see the row total and column total. And row total is 2 and column total is 10. The least value is 2. So write down the 2 and take the 2 from 10. You will be getting the value as what means 8. So you are eliminating your second row here. And then the remaining what you are having here is 1, 2, 3, 1. So 1, 2, 3, 1. You can write your corresponding supply and demand, and then you can start your penalty value, calculating your penalty value. That is 2 minus 1 is 1, 3 minus 1 is 2, 3 minus 1 is 2, 2 minus 1 is 1. So these are all the penalty values we are having. Among this penalty values, 2 is the maximum. So actually the 2 you are having in 2 places. So in that in the 2, any one you can take it. That is any one, anything you can take it. But here, what's the thing we are having here means this 2, this column 2, this value only we are taking. In this row we are having the least value as 1. In this least value, the corresponding total value is 10 and supply value is 11. Among these two, 10 is minimum, so you are writing that 10 corresponding to 1, and we are taking this column separately. And what is the remaining we are having here means 1 and 3. There is no need to take any penalty value. In that one, you can choose which is the minimum value. 1 is the minimum value here. And in this one, you see 8 and 7. 8 and 7, if you are having means 7 is the least element. So 7 you can enter it. Take that 7 from 8. You will be getting it as 1. So directly you will be getting 3, 1, 1. It is nothing but the balanced problem. So it is a balanced problem means what is the remaining thing you will be having there means uh, for this 3 you can allocate it as what means 1. So you'll be getting the values as what here means the remaining table can be written like this. The starting solution is as shown in the following table. That is all. Once again, you have to write down all the values under the corresponding and the corresponding allocations also you have to do it there. Under the initial transportation cost, you can calculate it. That is 1 into 3 plus 0 into 2 plus 2 into 10, 3 into 1 plus 1 into 10. Will be getting the value as 40. You'll be getting the value as 40 means you see from the northwest corner rule what's the value we have got it. The value from least cost is 61. and the value what we have obtained from the northwest corner rule. Northwest corner rule, what's the value we have obtained here means northwest corner rule is 94. Least cost method is least cost method is 61, and by Vogel's approximation method, the value what we are getting here is 40. So among all these values, you can identify easily that 40 is the least amount. So 40 is the least amount means it could be the best method among all these three method. Which method is the best one means VAM method only, that is Vogel's approximation method only. So we can conclude that for calculating the initial basic feasible solution, Vogel's approximation is the best method. And the overall sum up for this unit is generally transportation problem as a number of origins and destination. Whatever may be the origin and destination, a certain amount of consignment is available in each origin. Similarly, each destination has a certain demand or requirements. The transportation problem represents amount of consignment to be transported from different origins to different destinations so that the transportation cost is minimized without violating the supply and demand constraints. And there are two phases in the transportation problem. First is the destination of basic feasible solution. Second is the determination of optimum solution. In this section, it deals about the basic feasible solution, and there are three methods available to determine the basic feasible solution. They are northwest corner rule, least cost method or matrix minimum, Vogel's approximation method. This is nothing but the thing what we have did so far. And some of the keywords are feasible solution. A solution is said to be basic if the number of positive allocation equals to m plus n minus 1. That is, if our allocation is equal to m plus n minus 1, that is number of rows plus number of columns minus 1. If our allocations are equal to this one means it is said to be called as non-degenerate. That's a thing they have given to you as uh, and this is one, that is one less than the number of rows and columns in the transportation problem. So if you are finding any solution means it should be, that is if you are finding the allocations means it should be equal to m plus n minus 1. That is said to be called as feasible solution. And the basic feasible solution is if the number of affirmative allocations equal to m plus n minus 1, the solution is considered to be the basic feasible solution. And this is a two thing you should know it properly. And the terminal questions are here. Explain an algorithm for solving the northwest, that is for solving the transportation problem. Algorithm means already here you are having three algorithms. That is what's the thing we are having here means northwest corner rule. Here we are having these things are the algorithm 6.4 northwest corner rule, 6.5 least cost method, and 6.6 Vogel's approximation method. So all these things are the algorithms for solving the transportation problem. You have to write it briefly there. And then our next terminal question is nothing but what means explain briefly with one example about northwest corner, least cost and VAM method. The example what we have seen now, that is nothing but the best example for solving the transportation problem by using northwest corner, least cost method and Vogel's approximation method. And one more example they themselves have given here. You need to solve the given transportation problem. That is four companies W, X, Y, and Z supply the requirements of three warehouses A and B and C. Four companies are that is satisfying the requirements, that is supplying the requirements of the three warehouses A, B, and C. This is a thing. And the company's availability, warehouse requirements, and the unit cost of transportations are given in the following table. Find an initial basic feasible solution using all these three methods. That is, company W supplying to warehouse A. Here warehouse B, warehouse C, everything is being given here. And the supply value for this company W is 5. And the demand value for our warehouse A is 7. So the supply value and the corresponding demand value, everything had been given in the table itself. Now you have to check whether the supply total and also the demand total are getting balanced. If you're taking a supply total value means 5 plus 8, 13, 13 plus 7, 20, 20 plus 14, 34. Your demand value 7 plus 9, 16, 16 plus 18 is 34. So that supply values and demand values are getting balanced here. Now you have to start our question by solving by northwest corner rule, and also once again by using least cost method, and by using the Vogel's approximation method. Now, what are all the things so far we have seen here means, the things what we have seen here means nothing but an introduction part, and the overall sum up. How can we solve our given question by using northwest corner rule, a least cost method, and also Vogel's approximation method? All these things we have seen, and the brief explanation in words also have been given here. That is, first thing is an objective. The main objective is to check your problem is balanced or not, and to get an initial basic feasible solution for our given problem. And the methods for finding hints, three methods are there, that it is nothing but northwest corner, least cost, and Vogel's approximation method. So all these three things are the best method for finding the initial basic feasible solution. Among that, Vogel's approximation method is the best method, because we will be getting the minimum transportation cost by using that method only, and the overall sum up and the keywords, and the terminal questions was also given there to practice for a given problem. And the worked out by seeing the worked out example here, everybody can understand how to start our allocation by using northwest corner. Before going up for our problem, for each problem you have to check whether the given problem is the balanced one. Given problem is the balanced one. By if it is balanced only, then only we can move for all the four, that is all the three methods. Otherwise it is not at all possible. So northwest corner means you have to start your allocation from the topmost corner. If you are starting your allocation, and then you have to see the corresponding supply and demand total. If it is supply and demand total, among that one you have to see which is the minimum value. That minimum you have to take it out, and then you can cross out for the further calculation, and you can carry the remaining problem with your corner values itself. So this is a thing you have to do for our northwest corner rule. And least cost method means, least cost method, you have to start your allocation in the minimum cell value. You can start your value from the minimum cell value, and similarly you can see the corresponding row and column total. The minimum you can take it as for our allocation. That thing you should not take for the further calculations. And you can calculate your total transportation cost from that one. And the next thing is nothing but the Vogel's approximation method. In the Vogel's approximation method also, you have to calculate initially the penalty value. The penalty value is nothing but what means minimum minus next minimum. That is next, you have to take minimum and also the next minimum, and then the two elements should be subtracted and it should be written in the bracket outside the table. In that one, you have to check which one is the highest penalty. The highest penalty value, among that highest penalty value, you have to choose your minimum cost. In that minimum cost only you have to start your allocation, and then you can start your total transportation cost from the given thing. So these, and you can if you're calculating the transportation value means, you can check up which method will gives you the best answer among these three methods. Normally, Vogel's approximation method is somewhat comfortable, and though the process is very big, the Vogel's approximation method is the best method for finding the total transportation cost. So remaining we will see in the next unit. Thank you.